let us understand the applications here. Say, if you see, the topic is sequences and series, and just see the sequence of our hand. This is from the finger, two parts, and till the end of your palm, they are arranged in a sequence. God is great. God is great. Similarly, whatever the cyclone announcements or any calamities they announce, they're all nothing but they take a sequence. This is the shell in the sea. You might have seen that shell. The inside structure of shell, it gives a Fibonacci sequence. That Fibonacci sequence you don't have in our syllabus. We don't have that. In the higher level of mathematics, you will be learning that. Even if you take this is a shank. If you take a shank like this is also gives you a sequence. And if you see this tree is also having its leaves are also arranged in a sequence. I see the मयूर, इसका भी देख लो, जो पूरा universe is simply filled with sequences and series. So I have taken some examples. There are many examples out there if you see. So sequence and series. Sequence is mentioned with commas in between, and the series is shown with addition in between them. So according to our syllabus, we have only 3 to 4 different sequences and series are there. That is, number 1, it is arithmetic progression. I need not to tell you that. Number 2 is geometric progression. Number 3 is harmonic progression. Number 4 is Arithmetico geometric progression, which is known to be AGP. Okay. So this is what I'd like to tell you here about the applications of sequences and series. The entire universe is filled with sequences and series. So let me show you the problematic part of this one. Problematic part of this applications. If you see, did I share the screen? No. Just a moment. Prathamesh, good morning. Chatting का good morning है वो कर लिया हमने. Share the screen. Sharing the screen. Yeah. Now, if you see some applications in the problems, that is, while solving the problems related to the progressions, we call it as progressions or sequences and series and all. Okay. If you see this, a shop assistant is arranging a display of a triangular array of tins so as to have 1 tin in the top row, 2 in the second, 3 in the third, and so on. If there are 66 tins altogether, how many rows can be completed, arranged? Oh, this is a sequence which is forming an AP here, This gives you the answer. If you want to have 1 on the top, and the height, if you take that height, will give you the number of tins that are to be arranged. Similarly, a restaurant has square tables which seat 4 people. When 2 tables are placed together, 6 people can be seated. If 20 square tables are placed together to form 1 long table, how many people can be seated? If 1,000 square tables are placed together to form 1 very long table, how many people can be seated? This will give you a sequence. Okay. Similarly, these are all the application problems. A culture of bacteria doubles every 2 hours. If there are 500 bacteria at the beginning, how many bacteria will there be after 24 hours? 24 hours. After 24 hours, how many bacteria are present? That means this is practically the application for even the bioscientists. Nowadays, you can see the virus is prevailing, coronavirus is prevailing, and the calculations, all these are based on this, how they are developing and all this. In fact, the entire history of corona is not known even to the doctors also. Just every day they are giving us new news. So these are also calculated. You can have the application of the sequence and series even in calculating this bacteria and viruses also. So recent estimates based on data from satellite observations report 775 million hectares of rainforest remaining. The average annual rate of deforestation in the world is 0.77%. How many million hectares of rainforest will be lost in the next decade? The answer is also given here, 57.65 millions. This is application. Similarly, how arithmetic sequences are used for and used in conjunction with a series can be used to sum up a list of numbers, can be used to sum up prices. Theater tickets sold for $60 for odd number tickets and $40 for even number tickets, and there are 50 seats in the theater. How much money do even tickets bring in if all are sold? What are geometric series used for solving? Compound interest. Geometric series, please. Similarly, a doctor suggested a patient who has undergone a knee surgery, and his trainer tells him that he suggests jogging for 12 minutes each day for the first week. Each week thereafter, he suggests that you increase the time by 6 minutes per day. How many weeks will be there before you are up to jogging 60 minutes per day? This is the application. Okay, you visit a Grand Canyon and drop a penny off the edge of a cliff. The distance the penny will fall is 16 feet the first second, 48 feet next second, 80 feet the third second, and so on in an arithmetic sequence. What is the total distance of the object will fall in 6 seconds. It takes either a series, a perfect sequence, a series will be taken and it can be calculated. Similarly, real world examples, real life applications, bank account, if you invest the money and the growth of the money is calculated. For example, the interest is given with 5% and it takes the geometric sequence. Similarly, viral videos, nowadays it's a famous word, viral videos. A video is watched by 10 people, 3 hours later, 100 have watched it, and 3 hours later, 1,000 people have watched it, etc. This video is being watched by a factor of 10 every 3 hours. 3 hours. So that forms a sequence again. Similarly, see the nature, the beauty of the nature. This is a flower. This flower is having a sequence here, just to see the sequence, whatever the direction, the beauty of the universe. God is great. He has created so many things in the sequence like this. This is also a flower, you can see. The sequence here. The sequence, this is, I said, no, this is a shell. This is a shell, and this is, in fact, there are in the higher level mathematics, there are applications of sequence and series, and this is said to be Fibonacci sequence. Fibonacci sequence is, you will have, if you go for higher level mathematics, you will have all these sequences. Just see, these are all the, based on sequence only, how this may be arithmetic progression in a sequence, and because from smaller object to the bigger object, you can see they are moving like this. Similarly, this is Hungi, Schenk. This forms a sequence. Just see the natural sequences. Similarly, if you see the tree, wow, what a beautiful arrangement in the universe. Just if you see the sequence here, this is also for each of the leaves there is a sequence, and again for the entire this one you have a sequence again. So it is in the increasing. This is in the increasing order from the this corner to the tree root. Okay, so similarly the same here also there is a sequence formed. Do you recognize that girl behind the tree? Anyone in the class?
No, sir.
No? Jahan did not recognize?
No, sir.
That is nothing but Priyanshi. Priyanshi is there in the class?
Yes, sir.
Yeah. This is Priyanshi only behind that leaves. Okay. Is it not Priyanshi?
No, sir.
No, sir, she is ugly.
Okay. This is a Mayur, and you can see a beautiful. Everyone likes this. This also forms a sequence. Yeah, so see that this is a sequence. So this is a nature application. If you see this is desert flaps, desert trees. If you see now, particularly desert trees, if you see now, they will have a sequence, and this gives you a geometric series. This gives a geometric series, and the hand I have shown you beautifully. I also never observed this because I want to teach you. I searched in the internet and I have got this very nicely. You can see it is arranged in the arithmetic progression. First term, second term, third term, fourth term. See the beauty, the creation of God. In the human being also the series are present. If you see these fingers, smaller finger, and ring finger, middle finger, and this one. These are all, you can see a sequence here. Similarly, whatever the things are there, even in the feet fingers, just to see the beauty of sequences and series here. This is also forming a sequence, and it is also whatever the entire body structure is giving you. Okay, so similarly, the universe, the cyclone and calamities, whatever the changes, weather report, whatever you get, it is taking a shape. Just see, it is taking a shape of a shell. If you see, no, this is also a sequence. Similarly, whatever the lungs are there of our body, they are also arranged in a sequence. Nowadays, to save the lungs is very, very important because coronavirus is attacking lungs only. So that's the reason why it is also arranged in a sequence. You can see if you save your lung, everything of your body will be saved. So pranayama is ultimate method to save your lungs throughout your life. What I'm suggesting you, please do it. You are the young generation, and you are the face of the country. So this is how I like to show you the applications of the sequences and series. Now let me continue with the formulae that are present in sequence and series, and this is a synopsis. Just every one of you, please remind them and revise them, because you will have to, I think, remember up till the end of June. Yes, Dhananjay.
Sir, do we have weighted means?
Generally, they are not there, even though they are given in the syllabus. It is not mentioned. Never the question also asked so far. Okay, Dhananjay.
Yes, sir, thank you.
Yeah. Now, let us say this. Progressions, it is not necessary that the terms of a sequence always follow a certain pattern. They are described by some explicit formula for the nth term. Those sequences whose terms follow certain patterns are called progressions. So far, I have shown you many patterns. And you may be surprised how that forms a pattern, sir. Yeah, that forms a pattern, definitely. Whatever the patterns are there in the universe, even if you take Taj Mahal also, it is, if you see from the forefront, that forms a sequence. So it gives you an nth term. Similarly, in the higher level mathematics also, for all the series you will have a sequence, but according to our syllabus, we have arithmetic progression. Similarly, what is a sequence? Is a function whose domain is in the set of n natural numbers. Why set of n natural numbers? Set n of natural numbers, because the first term, second term, third term, fourth term, like that we must have. So that is the reason why domain is set of n natural numbers, and sequence whose range is subset of R. The range can be any real number. So if A1, A2, A3, so on, An is a sequence, the expression A1 plus A2 plus so on plus An is a series. So progression will have some nth term. Arithmetic progression now. Arithmetic progression, I need not have to, I think, insist on it, because everyone must be remembering that from your 10th class itself you have this. So the general term of AP is A plus n minus 1 into D. I'm showing it, please just say this. A plus n minus 1 into D. Every one of you just visualize this. Visualize this to remember, because you will be having for again the exams in the next year. June means you have to remember at least for 8 months. At least for 8 months till the completion of your exams. So nth term is equal to n by 2 into 2a plus n minus 1 into d, and it is also said to be n by 2 into a plus l. If you know the first term and last term also, you can write the sum of n terms. Similarly, if you are given sum to n terms of a sequence, then if you want the nth term of that sequence, then the nth term is simply sum to n terms minus sum to n minus 1 term. Nth term is nothing but sum to n terms minus sum to n minus 1 terms. Okay, that is also an important point to be remembered. And do we have this sequence and series in MHCET, please?
Yes, sir.
Yes, sir.
Yeah. Then this is ABCR in AP, and I need not have to tell you that these are the direct formula you have to remember, and you have been applying this formula from your lower classes itself. ABCR NP, then 2b is equal to a plus c. Next, any constant term is subtracted or added, then AP remains AP only. Any constant term is subtracted or added to the series to AP, then that remains AP only. Similarly, added or multiplied or divided by a non-zero constant, also AP remains AP only. So addition or subtraction or multiplication or division to each and every term of AP makes it AP only. It remains as AP only. There will be no change at all. Okay. So, and fourth one is very, very important. Fourth one, if you see, in a finite AP, the sum of terms equidistant from the beginning and end is always same and is equal to the sum of the first and last term. Very, very important, please. Based on this only, you have good number of problems. Good number of previous problems. What I mean to say, first term plus last term is equal to second term plus last but one term. Third term plus second from the last. Like that it is, and it is very simple. We can understand that by taking a simple numerical example, 1, 2, 3, 4, 5, 6. If you take what is 1 plus 6, 7, what is 2 plus 5, 7, what is 3 plus 4, 7. That's what the meaning of it. That's what the meaning of it. The sum of the terms equidistant from the beginning and ending is always same and is equal to sum of the first and last terms. So based on this, theoretical questions will be formed. That is, if I say this as A1 and if I say this as AN, A1, AN, A2, AN minus 1, A3, AN minus 2, then I can say A1 plus AN is equal to A2 plus AN minus 1, A3 plus AN minus 2. That's what is given here. That's what is given here. These are all equal. If you know A1 plus AN, you can find out the sum of that AP by simply multiplying this with n by 2. So n by 2 into first term plus last term gives you the sum of all the terms. Sum of all the terms. Okay. So these are the properties of AP, please. Properties of AP. A sequence is an AP if and only if its nth term is a linear expression, that is Tn is equal to An plus b, where A, B are constant. In such a case, the coefficient of n is Tn is a common difference of the AP. Okay, we will be understanding that in the problems, no problem at all. Similarly, the sum of its first terms is a quadratic An square plus Bn. That is understood through the formula itself. If the terms of an AP are chosen at regular intervals, then they also form an AP. This is a common sense point. 1, 2, 3, 4, 5, 6 are there. If you, this is AP, and choose the terms that are equidistant. That is first term, third term, and fifth term. This is also forming an AP. Similarly, second term and fourth term and sixth term, this also forms an AP. That's what he means to say. If the terms of an AP are chosen at regular intervals, they form an AP. They form an AP. Okay. Next is selection of terms in an AP. You must be remembering that the terms, 3 terms are to be taken. What is the advantage by taking like this? I'll let you know that. 3 terms of an AP are to be chosen as A minus D, A plus D. Common difference is D. 4 terms are to be taken as A minus 3D, A minus D, A plus D, A plus 3D. What is the common difference? 2D. 5 terms of an AP are given A minus 2D, A minus D, A plus D, A plus 2D. Common difference is D. And 6 terms A minus 5D, A minus 3D, A minus D, A plus D, A plus 3D, A plus 5D. Common difference is 2D. So you can see that common difference 2D comes for the even number of terms and D comes for the odd number of terms, and it is common sense. You can understand that because you have applied this, you have done the model problems on this in your lower classes itself. So what is the advantage by taking like this? You see any such terms here, some D eliminated, some D eliminated, some of these terms D eliminated, some of these terms D eliminated, and thereby you'll get the value of A. That is the advantage. So 3 terms, 4 terms, 5 terms, maximum it will be 6 terms. It will be given like that. Whenever the terms are to be taken like that, you can take, of course, this one. You can take, of course, the terms, 3 terms as A plus D, A plus 2D. That is there always. But the advantage in this one is D gets cancelled in the summation. In the summation, D gets cancelled. You get A directly. That is the advantage. And you can proceed with this one also. No problem at all. But that will be little lengthy in simplification. That is the advantage. So for the sake of simplification, we do it like that. Okay. Now, insertion of arithmetic means. Arithmetic mean, if A, B, C are in AP, B is said to be AM. A, B, C are in AP, then B is said to be AM. B is equal to A plus C upon T. So, whenever A, B or 2 terms are there, then AM is nothing but A plus B by T. So, insertion of remember, among all this, the point to be remembered is that D is equal to B minus A by N plus 1 is if you want to insert N AMs between A and B, if you want to insert N AMs between A and B, then common difference is to be remembered like this, B minus A by N plus 1. I'll tell you one relation here, listen to me carefully, AP and GP. AP and GP, what makes the difference, you know? AP is related to summation and GP is related to multiplication. AP is related to summation and GP is related to multiplication. Summation here will be converted as product and subtraction here will be converted as division. And multiplication here will go to the power symbol. Power will go to the power. This is what you have to understand, please. So, anyone in the class, if D is equal to B minus A by N plus 1 is the formula to insert N AMs between A and B, anyone, do you tell me what should be the formula for R, common ratio, to insert N GMs between A and B? B minus A.
Sir, B by A the whole raised to 1 by
B
N plus
minus
1.
A becomes B by A. 1 by N plus 1 is multiplied. That will go to the power. Understand this relation. Then you need not have to by heart. So this is the hint I can give you so that all the arithmetic progression properties can be transformed to geometric progression properties. Okay, so that's about the insertion of N AMs between between two numbers A and B. And sum of AMs, there is a formula for this also. Of course, without this also, you can do that. You will understand easily. This is sum of n AMs is nothing but n into A plus B by 2. N into A plus B by 2, rather, you can say it as n into A between A and B. N into A between A and B. This is after this simplification only you will be getting this. Similarly, anyone please? Anyone? Now, here, sum of n AMs is given like this. Anyone, do you transform this formula to the product of n GMs? Anyone in the class, please? N GMs? I'll give you a hint also. N by 2 into A plus B. Yes, Dhananjay. Yes, Dhananjay, I'm with you. N by 2 into A plus B. Just now I said AP plus is converted as product in GP. And multiplication goes to the power AB whole power n by 2. Srivardhan, are you there?
Yes, sir.
Parsh,
Yes, sir, I'm there.
Jahan, Sanket, Sakshi,
Yes, sir.
Sanskar,
Yes, sir.
Priyanshi,
Yes, sir.
Arya,
Yes, sir.
Hit.
Present, sir.
So the summation in AM will become multiplication in GM, and the multiplication in AM will go to the power like this. That is why summation has become product here. So sum of n AMs is n into A plus B by 2 or n by 2 into A plus B. And product of n GMs will be AB whole power n by 2. That's what I'm going to show now. Just say this. Now next is geometric progression. And what is the difference between that and this? There in AP, D is equal to Devsha, yes.
Sir, so there is no difference between the formulas of summation of AM and summation of an AP.
I did not get you.
Is there any difference between the formulae of summation of AM and summation of AP?
Yeah, in AM means you will be taking the terms between A and B, between only, and AP means A and B also included.
But the formula given over here is the same.
No, yeah. Yeah, sum of the terms of AP n by 2 into 2A plus n minus 1 into D. ये तो मैं बताने की जरूरत ही नहीं है.
A plus, I was talking about A plus L.
That's what I'm
First term and
saying.
last.
Here there are n ANs between A and B है तो हमको सिर्फ इसका सम चाहिए बेटा. A and B excluded here. In this case, it is n by 2 exclusively for sum of n AMs.
Yes, sir, I got it.
So D is equal to an minus an plus 1 hai. That means the common difference in AP is an minus an plus 1. Sorry, this is an plus 1 minus an. Okay, anyone, do you convert this to GP now? This D becomes R here. This minus becomes what?
Division.
That's it. That's what it is. You understand this relation so that everything from AP can be converted to GP. So common ratio is n plus 1 upon an. So that's only the difference between arithmetic progression and geometric progression. And the terms that have to be, the formula that have to be remembered, nth term of GP, Tn is equal to A into R power n minus 1. Okay. Similarly, sum to n terms of GP, sum to n terms of GP, you can see This is just now, Parshva was telling this, and rest of the people must also know this. A into r power n minus 1 by r minus n if r is greater than 1. These two are given as two different formulae. Of course, there's only one formula. If you take minus common here, you will get this formula. That is why remember one formula, that will be sufficient. A into r power n minus 1 by r minus 1. Similarly, if you take S infinity, this is frequently used in all other topics also. A by 1 minus r. Those who are forgetting this formula, just for your sake only, I am revising this. And very, very important point in the objective questions, what they concentrate in the infinite series. These infinite series are valid only when mod r is less than 1. What is the meaning of mod r? Whatever r is there, this r must lie between minus 1 and plus 1. Otherwise, it is not valid. Infinite series is not valid. So, infinite series is valid only when the value of r lies between minus 1 and plus 1. Okay. So, here it is common sense that a is the first term and r is the common ratio and is the number of terms. And generally, in working out the problems, there is a little confusion in the students in applying this summation formula. Just I'd like to clarify that by showing this series here. Just to say this, everyone, please listen to this carefully. What is the nth term here? Anyone do you respond?
A into r raised to n minus.
Correct. Now, if the sum of all the terms are to be taken, then this r power n minus 1 becomes r power n. Remember that.
Yes, sir.
There is a little confusion in this part while working out the problems, whether you or me or whoever it is. So, the last term power will be in the summation, will be added with 1. So, remember that, and you will be understanding it working out the problems. Okay. So, similar to the characteristics of this one also I have to show you. Similar to that, a minus d, I'll show you how that is converted here. A minus d, a plus d, isn't it? This, what I said, the subtraction becomes division. That's what you can say. Subtraction becomes division. A remains a, addition becomes multiplication. So you don't need to remember them separately. That's what I mean to say. Okay, a by r, a r. What is the advantage here? There in addition, d gets cancelled. Here in multiplication, you can see r gets cancelled. There you will get 3a. There in summation, a minus d, a plus d, you will get summation. Here you will get this summation 3a. It is multiplying, no, then it will go to power here in geometric progression. AQ. See the relation there? That's what it is. If you observe this, it goes very easy for you. Okay, so all the terms are written like that. So that purpose is to get a variable. If the question is given with the two conditions for a and r, if you take the 3 terms like this, or 4 terms like this, or 5 terms like this, straight away one variable will be cancelled and the value of another variable comes. Okay. Similarly, the properties of geometric progression is very much similar to arithmetic progression, provided you understand how to transform AP properties to GP properties. If a GP is multiplied or divided by the same non-zero constant, addition and subtraction are ruled out here. Addition and subtraction becomes, what happens to addition? Addition becomes a multiplication and a subtraction becomes a division. In case of GP, then GP remains GP only. The reciprocals of terms of a given GP form a GP. If each term of GP is raised to the same power, then the resulting sequence also forms a GP. raised to the same power, a1 power k, a2 power k, a3 power k. Then again it becomes a GP. Similarly, similar to AP, there the terms that are equidistant, from the beginning and ending forms an AP. Here also the same property. What is that? A1 plus AN is equal to A2 plus AN minus 1 is equal to A3 plus AN minus 2. Then what will happen? The same property in case of GP, that plus becomes into. That plus becomes into. This plus becomes into. Just understand that. That's what the property must have been given here. In a finite GP, the product of the terms equidistant from the beginning and the end is always same and is equal to the product of the first and last term. That's what it is. He has taken K there, and I have shown you with N like this. This is common sense, and if you want me to show through a numerical example, 1, 2, 4, 8, 16, 32 are there, then 1 into 32 is equal to 2 into 16 is equal to 8 into 4. This is what he means. This is what he means. Okay, next. If the terms of a GP, and this is also important, please. This is also important. Seems to be very simple formula, but you will have to make use of this, and for if it is AP, what is the property? Anyone, if they are an AP, what is the property? Anyone, please do a respond.
2b equals a plus.
2b is equal to a plus c. That's great, Parsha. Can you convert this to GP now?
Yes, 2 will become power and plus will become multiplication.
Very
So
good.
b square is
That's it. He got it. He got it. I'm giving you a technique to remember or to transform all the formula of AP to GP. That's what it is. B square is equal to AC. If the terms of a GP are chosen at regular intervals, then the new sequence so formed it also forms a JP. And A1, A2, A3, so on, AN is a GP of non-zero, non-negative terms. Then their logarithms are in AP, please. Then their logarithms are in AP. Important property plays if you take B square equal to AC, apply log here, 2 log B is equal to log A plus log C. Understand this? Okay. Then log A, log B, log C are in AP. So GP applied with logs becomes AP. GP applied with logs becomes AP. So next is insertion of geometric means. I need not have to discuss that. The GM between two terms A and B is nothing but root AB. The GM between two terms A and B is root AB. How to convert this from AM to GM? There it is, A plus B by 2. AB becomes, A plus B becomes AB. Half is multiplying, goes to the power. That's what it is. G is equal to root AB. Okay. If you insert n GMs between A and B, then the product of n GMs, just now I said, in AP it is n by 2. Sum of n AMs is n by 2 to A plus B. In GP it will be plus becomes into and n by 2 goes to the power. That's what it is. Okay. Next, coming to the harmonic progression, please. Harmonic progression, you don't have separate formula for harmonic progression, but just understand harmonic progression. If you take any sequence for harmonic progression, their reciprocals must lie in AP. So every problem in harmonic progression will be solved by finding their reciprocals and applying all the formula related to AP only. So HP is equal to 1 upon AP. HP is equal to 1 upon AP. This is what you have to understand. Okay. Next, insertion of HMs between two given numbers. Again, you have to follow the AM procedure only, like what it is. whatever the HMs you take here, just observe that whatever the HMs you take here, finally what is that we are doing? We're converting them to AP. And again, we are applying all the properties of AP, and we have got D here. What is, anyone, do you remember what is D in case of AP, please?
B minus A upon N plus 1.
That's good. Similarly, here, if you find out in a similar manner, you got D is equal to B, A minus B by N plus 1 into AP. So, what is the important thing to be remember in HP? What I suggest you is HM between A and B. HM between A and B. HM between A and B means simply you have to remember like this: 2 divided by 1 by A plus 1 by B. It is nothing but 2AB by A plus B. Nothing but 2AB by A plus B. What is HM between 3 terms ABC? Anyone in the class?
3 upon 1 upon A plus 1 upon B plus 1 upon C.
That's good. I suggest you remember this. Remember this. Okay. So that's what it is given here. It is given here. See this one. 1 by H is equal to 1 by A1 plus 1 by A2 plus 1 plus 1 by A divided by N. This is nothing but this 1 by H. Why he wrote 1 by H here? He converted to AP, and then it is we have to write the reciprocal of it to get HM. To get HM, we have to write the reciprocal. That's what I wrote just now. Okay, and let me show you, because for the purpose of problem solving, AM between A and B, A plus B by 2. GM between A and B, root AB. HM between A and B, 2AB upon A plus B. These three will be used. See here, this one. This one I'm talking about. This one I'm talking about. Okay. These three you have to remember, and very, very importantly, in all the other topics also, what we use is AM is greater than or equal to GM is greater than or equal to HM. So among all the three, AM is higher value, next to GM, next to HM. All these three will be equal if A and B coincide. All these three will become equal if A and B coincide. Let us see the property given here. So that's what he wrote also. He wrote the same, what I explained. A is equal to A plus B by 2, G is equal to root AB, H is equal to 2AB by A plus B, and A is greater than or equal to GM is greater than or equal to HM. In finding the minimum maximum values, we make use of this. And obviously, AGHR in GP because square of G is equal to product of A and H. Okay, so this is what you have to remember. Okay, then this will be straight away given as objective question. The fifth one, please. Fifth one, A power N plus B power N upon A power N minus 1 plus B power N minus 1 is the AM, GM, HM between A and B for N is equal to 1. Right, N is equal to 1 here. A plus B. A power 0 plus B power 0 becomes A plus B by 2. If you put N equal to 1, it becomes A plus B by 2. So it is to become AM, N must be 1. It is to become GM, N must be 1 by 2. It is to become HM, N must be 0. So all three questions brought under the same point here, synopsis now. That is the reason why it is given at a stretch. If you remember this, you can instantly answer such questions. Okay, now finally, Arithmetico geometric progression, AGP. Generally in AGP, the first term should be, to apply all these formula, the first term should be A only. Just check it out. First term should be A only. That means even if it is not there, you have to make it A into 1 by taking some term common here. So sum to n terms of GP, is a little bigger formula, but it is inevitable you have to remember, or otherwise you once you revise the derivation of it, so that if you derive it, you will remember that easily. So sum to n terms of GP, Sn is equal to a by 1 minus r plus dr into 1 minus r power n minus 1 by 1 minus r whole square minus of a plus n minus 1 into d into r power n divided by 1 minus r is sum to n terms of AGP. Sum to n terms of AGP. Okay. If r is 1, that becomes sum to n terms of AP. Generally, I used to say with the students, generally you will not be getting the formula. No, you will not be getting the application of this formula in solving the problem, sum to n terms of AGP, because it's a bigger one. It should not be given in the objectives generally, but somehow I'm withdrawing that statement. Somewhere I observed the same question. I think maybe the previous examination, somewhere I have seen this, but you also verify that. And if it is there, it is inevitable, you have to remember this. But here, this is very important. But you have to remember sum to infinite terms of AGP, a by 1 minus r plus dr by 1 minus r whole square. A by 1 minus r plus dr by 1 minus r whole square. Okay. And you have special sequences, that is sum of the first n natural numbers n into n plus 1 by 2, sum of the squares of first n natural numbers n into n plus 1 into 2n plus 1 upon 6, and sum of the cubes of first n natural numbers n square into n plus 1 whole square divided by 4. And some other telescopic series are there. I'll be discussing that in the problems. Telescopic series. Telescopic series means after simplification, you will get only first term and last term remaining. First term and last term only remaining. Rest of the between these two, all the terms will be getting cancelled. So all the terms, why they are said to be telescopic series? If you see from the telescope, you will have only the object at the end, and the beginning is your eyes. So this is eyes position, this is object position, only remains like a telescope. In between, we don't see anything. Okay, so that is why they are said to be telescopic series. I'll take an example and explain you so that you will get it revised. Like what? I'll take a series like this: 1 upon 1 into 2 plus 1 upon 2 into 3 plus 1 upon, that is not decimal please, into 3 into 4 plus and so on, plus 1 upon n into n plus 1. It is given like this. For example, I'm making it with another concept, limits concept I am trying to introduce in this one. That is limit of n tends to infinity, this series is given. Limit of n tends to infinity, this series is given. Then how to proceed with this one? Generally, you might have seen in the limits also, you'll get series. Then observe what I'm doing. I'm taking up this nth term. If nth term is not given, if nth term is given in the series, the problem goes easy for you. If nth term is not given, you have to create it. You have to create it. What I'm doing, I'm making it r into r plus 1. I'm writing the numerator 1 as r plus 1 minus r. And here for me, r runs from 1 to n. Under n tends to infinity. Observe this carefully. Limit of sigma, r plus 1 getting cancelled, it is 1 by r minus r getting cancelled, 1 by r plus 1. R runs from 1 to n. As n tends to infinity. Are you there? Are you there, everyone? Please, if you respond,
Yes,
Yes, sir.
it gives me energy. So what happens, if you expand sigma, what is that you're getting, Write 1 first. Then what is that you get? 1 minus 1 by 2. Write 2, 1 by 2 minus 1 by 3. Write 3, 1 by 3 minus 1 by 4. And so on. Write n minus 1, 1 by n minus 1 minus 1 by n. Write n, 1 by n minus 1 by n plus 1. Is the screen is clear to everyone?
Yes.
Yes, sir.
So what happens here? Observe.
सर टेलीस्कोपिक बन जाता है.
सब कट जाएगा. तो इसका पीछे का टर्म से कट जाएगा. So what is the terms remaining? What are the terms remaining in the summation here? Just you're getting first and last term. This is called the telescopic series. And if you understand the sequence like that, you need not have to work out this entire procedure. That entire procedure need not be done. You just have to write the first and last term. That's all. So only thing is you have to recognize it. Then what is its limit value? N plus 1 minus 1 upon n plus 1. So n by n plus 1, it is the numerator degree, same as the denominator degree, and the coefficient of numerator is 1, denominator is also 1 for the higher degree term. So 1 by 1 is the answer. So 1 is the answer for this one. This is called telescopic series. Further, we will be discussing this, but I'm just reminding you to recognize the telescopic series. Okay, now let's move on to the problems. Yeah. Now you start doing this. Because these are objective examinations, you need not have to work out the entire procedure. Whatever the techniques are there for cross verification, you can comfortably use it. Like what ABCD are 4 unequal positive numbers which are in AP given, then it should be true for all APs. It should be true for all APs. So take ABCD as 1, 2, 3, 4, no problem at all. Just verify the first one now. A, 1 by A, 1 by D, and 1 by B, 1 by C. This is 5 by 4. This is 5 by 6. 5 divided into 4 parts, 5 divided into 6 parts.
Sir, it should be C.
They are not equal, so A is wrong.
It should be C.
Go for B. 1 by A plus 1 by D. Just now we did 1 by B plus 1 by C. Not less than. 5 by 4 is greater than 5 by 6. So not B. Go to C. Yes. 1 by same terms given. Oh, okay. So C is correct. C is correct. Similarly, if you say this one also, 1 by B plus 1 by C. 1 by 2 plus 1 by 3. 4 divided by A plus D. A plus D is 1 plus 4, 5. And it is nothing but 5 by 6. It is 4 by 5. You may be getting confused how to decide which one is greater. Then take LCM. LCM is 30. So LCM is 30. Make this 630 by multiplying with 5. Multiplying this with 5. And make this 30 denominator, because LCM of 6 and 5 is 30. Multiply with 6. It is 24 upon 5 into 6, 30. Now you can decide which one is greater, which one is smaller. 25 by 30 is greater, and hence this is also correct. So the options are A, C, and D. I think it is quite clear for you all. Yes or no?
Yes, sir.
Yes, sir.
Yeah. Let me check the option once. This option is not given here. I think I have forgotten to write the correct one. Correct, that is key there. Okay, no problem. That is C and D only. Second one, in a GP, the product of first 4 terms is 4, and the second term is the reciprocal of the fourth term, the sum of infinite terms of the GP. Can you try this?
Yes, sir.
So let us take the terms as A, AR, AR square, AR power 4. So product is given to be 4. So A power 4, R power 7,
Sir, sub correct.
so correct. Is equal to 4. This first equation we got. Okay. Next one. Second term is reciprocal of the fourth term. AR is equal to 1 upon AR power 4. So A square R power 5 is equal to 1. Second equation. Yeah, Ved.
सर आपने a into r raised to 3 में लिखा
फिर से बता.
वो जीपी में एक टर्म मिसिंग r raised to 3
Just a moment, please. Just a moment. So I'll come to you. Just wait. 2 divided by 1 implies 2 divided by 1 implies A square R square is equal to 4. Implies AR is equal to plus or minus 2. Then substitute here. 2 implies A square into. अभी बोलो वो क्या कुछ बोल रहा है?
यस सर
कुछ बोल रहा था?
हाँ सर सर वो जीपी में एक टर्म नहीं लिखा है आपने
एकदम
ए आर क्यूब नहीं लिखा है इसलिए
ओ मैं गलत लिखा. अच्छा ठीक है. सिर्फ वेद ने देखा. करेक्ट है बेटा, करेक्ट है. ये क्यूब होना चाहिए ना. That's what, no?
यस सर
हाँ
Thank
सर.
you. Otherwise, it will kill the time.
सर √2 आता है. AR is equal to √2 आता है.
ठीक है बेटा. A power 4, that is R power 6. ये क्या है? A भी क्यूब हो जाता है. This becomes AR cube. So A square R power 4 then A,
सर हमें a by r square a by r ar and
वो भी ले
a
हाँ
by
सकते
r
वही
square लेते
ऐसा ही
हाँ
ले
वो भी ले
लेते थे
सकते वो भी ले सकते
ए उससे डायरेक्ट ए का वैल्यू
सर डायरेक्ट a का वैल्यू आता है
ठीक है
√2 या -√2 आएगा
तो आंसर आ गया
हाँ आ गया सब आए सब पर हाँ बराबर सर आया
2 स्क्वायर डिवाइडेड बाय 1 कर रहा हूँ मतलब 2 स्क्वायर किया तो ये a पावर 4 हो जाता है, a पावर 4 कट हो जाएगा। एक मिनट, ऐसा भी कर सकते हैं, लेकिन मेरे ख्याल से ऐसा करने से रूट निकल रहा है। The purpose of taking the terms is to get a value directly. This is 1 divided by 2 square implies a power 4 r power 6 divided by a power 4 r power 8 is equal to 4. So this a power 4 gets cancelled anyway, and you will get 1 by r square is equal to 1 by 4, r is equal to plus or minus 1 by 2. Now find out a from this. R is equal to plus or minus 1 by 2 implies from this one a square into 1 by 16 is equal to 1. A is equal to plus or minus 4. You'll get 4 values here. I'll show you that separately. You'll have 4 values here. How? S infinity we need a by 1 minus r. That means you'll get plus 1 value, plus minus another value, minus plus 1 value, minus another value. So you'll get 4 sets there, 4 sets. First set I'm writing in an ordered pair a 4 and r 1 by 2. First set. दूसरा set a 4 r minus 1 by 2. Third set a minus 4 r 1 by 2. Fourth set a minus 4 r minus 1 by 2. I think it is clear for you all. Apply S infinity. Let me show you one summation. Apply S infinity, please, for the first one. This is the first set. For the first one, let me show you S infinity. Anyone, do you tell me the options there? S infinity. Formula a by 1 minus r, important formula. 4 divided by 1 minus 1 by 2, 1 by 2. It is 8, please. 8. So D is correct. Similarly, you must get the rest of them also like this. So here all are correct. All are correct. I have shown you the method. And what is, if you are taking like that, are you getting the answer? Or Srivardhan?
सर उससे a की वैल्यू √2 आ रही थी
नहीं, प्लस और माइनस रूट ले सकते हैं, वो तो अलग बात है।
हाँ हाँ प्लस और माइनस √2 पर सर 4 नहीं आया पर उससे 8/3 और -8/3 आ रहा था पर फिर मैंने r की वैल्यू माइनस छोड़ दी तो मुझे लगा कि a और b d भी होगा
हाँ, Dhananjay was telling me A, B, C, D because the answer is shown there. That is why he is telling, or he got the answer.
आंसर लिखा
लिखा हुआ है ना, वो देख के बता दिया क्या?
नहीं सॉल्व किया
ठीक है, this is the method, please. This is the method. I am moving forward. जहान
Yes, sir.
क्या बोल रहा है तेरा महान दादा?
हाँ.
कौन है तेरा महान दादा पता है?
Parvez.
नहीं नहीं, मुराद जी देशा है ना, ये जहान देशा है ना, मुराद जी देशा की बात कर रहा हूँ। ये मुराद जी देशा महाराष्ट्र है गुजराती है? तेरा जहान
मेरे को नहीं मालूम.
मालूम, शर्म आना चाहिए यार, जी के रहेगा आपको, जनरल नॉलेज रहेगा, उसमें आंसर करना पड़ता है। एक CITD बोल के एक इंस्टीट्यूशन है, सेंटर फॉर CITD, सेंट्रल इंस्टीट्यूट फॉर टूल डिजाइन, CITD एक सेंट्रल गवर्नमेंट का ऑर्गेनाइजेशन। कल इसका एंट्रेंस हुआ था इधर हैदराबाद में, ऑनलाइन टेस्ट हुआ था, उसमें मैं क्वेश्चन देखा, हु इज द फर्स्ट नोबेल प्राइज विनर, जी क्या है उसमें, पॉलिटेक्निक होता है वो, मतलब पॉलिटेक्निक में 10th क्लास के बाद जो एंट्रेंस टेस्ट रहेगा उसमें, who is the first Nobel Prize winner? Anyone? Wow. How many are there in the class, Dhananjay?
So 29.
29 are there. Exclude me. 28. Who is the first Nobel Prize winner? And I'm telling you the questions given there.
Alfred Nobel.
Sorry. Who is the first Nobel Prize winner of India? That's right.
रामन ना.
कौन है?
टैगोर शायद.
ठाकुर है, करेक्ट।
सबसे फर्स्ट टैगोर.
रविंद्रनाथ ठाकुर, उसके बाद रामन को आया था। ऐसा है, what is the memorial constructed for Indian soldiers who fought in the World War I? What is a memorial constructed in the name of
इंडिया गेट ना. दिल्ली में.
हाँ, इंडिया गेट है, इंडिया गेट। ऐसा ही कोरोना वायरस comes under which group of viruses? किसको बता? सार्स है। ऐसा ये आएगा बेटा आप सबको, मतलब बाद में आप सब एक करना पड़ता है, ठीक है? अब देखो बेटा, ए बोल रहा है 3 positive real numbers ABC or an ABC is equal to 4. Then step B can be equal to greatest integer function B can be equal to, ठीक है? ऐसा क्वेश्चंस में आइडिया नहीं निकलेगा हमको, ABC क्यों दिया, ये ABC और AP दिया, उधर प्रोडक्ट दे दिया, क्यों दिया, ऐसा सोचना पड़ता है। ABC जब दिया हमको, ABC टर्म तो सिंप्लीफिकेशन में आना ही चाहिए, आने से ही हम कुछ कर पाते हैं, ठीक है ना? तो इसलिए हम कैसे स्टार्ट करना है इसका, how to start this, because ABC product is given. How to start this? AM is greater than or equal to GM. So what is AM of ABC? A plus B plus C by 3. And what is GM of ABC? Cube root of ABC.
So, but इन लोग ने बोला है कि ABC is equal to 4. And
Just
AP
a
math.
moment, Dhananjay. Let me finish. I'll get out of my idea. Just a moment. Now, you know, just now we have seen 2B is equal to A plus C is 4. 2B is equal to, let me change the color. Just a moment. 2B is equal to A plus C is the condition for AP. So let me write that A, instead of A plus C, I can write 2B. So 2B plus B upon 3 greater than or equal to cube root of 4. Then B is greater than or equal to cube root of 4. Okay. Then what is that he's asking for? He's asking for step of B. Step of B. So from this one, what is that you can conclude? What is that you can conclude? Cube root of 4 value. Cube root of 4 value lies between
1.5.
1 and 2. We'll take like this. We will take like this. Cube root of 4 lies between 1 and 2. Correct? So, therefore, your B must be greater than or equal to, I can say, step value. We need step value here, greatest integer.
1 now.
Step value is 1. Step B can be equal to, he's saying, can be equal to. No, equality you don't have here, equality. It lies between, that's it. So it may be equal to 1. So what is the answer, please, anyone?
So A.
Maybe 1. Greater than or equal to cube root 4. That means okay. That's what I'm writing. Just a moment. Just a moment. Wait. Just a moment. I'm writing that. We'll conclude this like this. Therefore, B is greater than or equal to 1. Implies greatest integer function of B can be 1. And Ved, अब बोलो.
सर पर b is greater than cube root of 4 दिया है ना, तो उससे ज्यादा भी हो सकता है कितना, तो फिर उसके आगे सब वैल्यू आ सकते हैं ना.
That's what I'm thinking.
1 के आगे.
Yeah, that's what I'm thinking.
हाँ सर, अगर हमने स्मॉलेस्ट वाली पूछा होता तो हम लोग 1 लिख सकते थे, पर लोग ने सब पूछा तो 1 2 3 4 आया.
Equal to है तो m is greater than equal to gm. If m is equal to gm, then that becomes 1. Otherwise, it may be any value, no? It may be any value. If for something like
Sub values are.
something like 1 by 2 given, 1 by 3 given, then in that case we don't take them. That the value is less than 1 is given, then we don't take that. I think it's clear for you. Let me check the answer. For this also, I did not type the key. Yeah. No, it is next question.
So
Yeah.
can you please send that theory PDF on the group?
Yeah, it is ABCD only, please. ABCD. Theory ka?
हाँ सर.
भेजूंगा बेटे, भेजूंगा.
Thank you sir.
Yeah. See you all in the next session. I'll send you that. As Dhananjay is asking that.
Thank you,
Thank you, sir.
I'll share that PDF.
Thank you, sir.
Have a good day, all of
Thank you,
you.
sir.
Thank you,
Have a
sir.
good day sir.
Thank you, sir. Have a good